Let's start our vector review. So as I said at the end of the previous video, we saw our Maxwell's equations contain vectors and vector operations. So what we want to do is we want to focus on building a strong foundation with our vector algebra, various coordinate systems, and vector calculus before we can get into some of the more detailed electromagnetic problems. So before we get into our first topic, our vector algebra, what we want to do is we want to spend a few minutes just going over some of the basic definitions and basic properties to make sure that everybody's on the same page. So let's start by defining what we mean by vector and scalar. So our vector is just a quantity that can be described by a magnitude and a direction. So quantity described by a magnitude and a direction. And so of course it's important that it has both of these two things in order to be considered a vector. Some common examples of a vector are velocity, force, and then if we get more sort of into our EMAG, we can talk about electric field intensity as being an example of a vector quantity. So sort of on the other side of things, if we don't have a vector, we have what's called a scalar. And so a scalar is a quantity that only has a magnitude, so it doesn't have any direction associated with it. So quantity that only has a magnitude. And so from classical physics course, maybe some examples of this you've seen are speed or time. Temperature would be another one. And then if we think about more in terms of our electronics, electromagnetics, electric potential or voltage would be a quantity that is a scalar value. And of course there are plenty other examples, these are just some common ones. So the final thing that we want to define in this video, just to make sure we're all on the same sort of page here, is a field. So I kind of threw that definition out loosely in the previous video. We talked about electric field intensity, magnetic field intensity, but what exactly is a field? Ultimately, it's just a function that's specifying behavior in a certain region. So it's a function that specifies a particular quantity. So it could be a speed, it could be a electric field, just some particular quantity everywhere in a given region. And so as I noted earlier with the examples, we said we could have a field for speeds, we could have a field for electric field intensities. So this can be, we can have scalar fields or we can have vector fields. So it's not necessarily we only have vector fields or we only have scalar fields. We can have one or the other, and we'll see that with several examples later on. Another thing to note is that in general, our fields can depend on time and or position. Time and or position. So of course we could think about in a given system, over time things might be changing, whether we're talking about voltages, electric fields. If we think about a physical example, maybe waves in an ocean, we can think about over time the position of the crest of the wave is changing, over position it's changing. So these are all things to keep in mind with our definition of the field. And hopefully these things will come into more focus as we look at some of this vector algebra review.